Welcome to Dynamic Foundry Group. I'm Sandeep Kulkarni. Welcome you all to this small video section. Today we are going to see a small video on surface and core hardness in the casting. So let us start the video. Checking casting hardness is one of the important tests for verifying the casting quality, especially the strength and physical properties. Many times we come across a situation where we find casting showing the surface hardness is more and the hardness inside the casting, that is we call it core hardness, is on lower side. I have come across one situation recently where one of the OEM company representative have asked me a question, a problem he is facing, that he is facing the problem of getting more surface hardness and lesser core hardness. So, and he want a solution for that, and he wants some detailed study on that from me. So I feel this is a good topic, and let us make a small video so that more countrymen watching this video will also get educated to handle the situation. So, considering that situation, I am making this small video. Surface hardness is the hardness taken on the casting surface, which is normally checked to clear the heat. This is most popular and accepted method worldwide. However, in some of the cases, if casting is having some issues like porosity, shrinkage tendency, or we can say open grain structure, cracks, or sometimes customer asking for checking this core hardness, that is the hardness inside the casting, which is taken from inner side of the casting. It may be casting area inside or it may be core area in the casting surface. Why surface hardness is always more? So let us understand now why the surface hardness is always more. Surface hardness will be always more as compared to core hardness. It is mainly because of fast cooling of the casting surface which get exposed to the air immediately after box being getting knocked out. Fast knockout or red hot knockout is also one of the major reasons for the surface hardness is always more than that of core hardness. Core hardness is less. Core hardness is a true hardness as it is undergoing the normal or natural cooling cycle as it is not directly exposed to the air after or during knockout. So the cooling rate at this area is always different than that of surface area or surface casting surface area. Here, the section variations core used will also plays an important role in solidification trend, which also has some impact of the hardness of the casting in core area. But even after that, the hardness in the core section is or core area will be always lesser than that of the surface hardness. Some of the guidelines for this problem and this to handle this situation. Many times we need core hardness to be improved. It may be, it may not be the same or equal as surface hardness because have already seen that surface hardness will always be greater than the core hardness. But by using better charge mix option, charge chemistry, and by improving solidification trend, and by controlling the cooling cycle, you can able to reduce the gap between these two. So we have to reduce the gap between the surface hardness and the core hardness, and for that we have to work on the charge mix, chemistry, solidification train, and cooling rate as well. Many times we find situation where the surface hardness is okay within limits, say 197 BHN, but there are other issues like shrinkage, porosity, or we can say microporosity observed in the core hardness area. Hence, the core hardness is uh, here the core hardness is too less about 162. So your surface hardness is 197 bhn, and there is some issues like shrinkage or porosity or open grain structure. When you cut the casting or you see the core hardness of that same casting, it is around 162. So there is a gap of almost 35 bhn between the core hardness and the surface hardness. Here, there are chances of C-type graphite in the microstructure matrix as well, which indicates that the metal is soft in nature. Because of 162 VHN is the hardness at core, we can find C-type graphite in the microstructure matrix. It directly or it indicates that the metal is soft. This data is from the OEM representative, which the problem has been there. The same data I have taken here. So it is a true case study, you can say. A gap of around 35 BHN is there, and they have observed C-type graphite as well as open grain structure, some shrinkage and microporosity in the casting while machining. Here, there is a possibility that surface hardness is achieved not because of the right charge mix and right chemistry, but due to the surface chilling and cooling rate. So we need to make necessary changes or fine tuning in the charge mix and the chemistry. Here, then we have to make some modification in charge mix and chemistry by adding some more percentage of MS, adding some more alloys, and by reducing carbon and silicon from the chemistry as necessary. By this, we can improve the core hardness from 165 to 187, 197 BHN, and by controlling cooling time or cooling rate, we can also maintain the surface hardness up to 207 to 217 BHN. Thus, the difference between surface hardness and the core hardness from reduces from 35 BHN to 15 to 20 BHN. So, by doing this addition of MS, by controlling the alloys and the cooling rate, we can reduce that gap of core hardness and surface hardness to maintain proper chemistry, proper charge mix. We can able to get good surface hardness as well as good core hardness, which will reduce your issues like you can say porosity or shrinkage or open cut structure. So this is from our side. Thank you very much. Hope you understand the concept of core hardness and the surface hardness, and also able to understand how to reduce the gap between these two. Thank you. Thank you very much.